Hello and welcome to another recitation session. In this, we will talk about the project 3 of your program in CSE259. This project is closer to what you've been learning in the class, and it's based on propositional logic. So let's jump directly into this project and see what's there for us. In this project, you have two files given to you. One is a PDF file and another partly written code in thmpv.pl. You should find this under modules, project 3. This code is partly runnable, just like you have had in the previous test program. And on executing a simple command like run p or q, p, it should execute and tell you yes. So let's try to understand what this program does in a little more detail. You have two parts to what you provide as an input. One is a premise, and the second is called the conclusion. Premise is the head of your code, of your formula or rule, and the conclusion is the body of your formula, of your rule. The idea is to replace various connections like conjunctives or negations, disjunction, implication with commas to build the formula as you see here below. You're provided with a space holder in the code where you're supposed to implement your entire code. And this is based on an algorithm called the Wang's algorithm. So let's try to understand the Wang's algorithm. Well, given a formula, the idea is to, as we discussed, is to replace the connections within the formula by commas. The binding is based on the type of connection that's provided, negation having the highest to the sequent being the lowest, with conjunction, disjunction, and implication in that particular order provided to us here. Each of this is replaced based on the rules of the Wang's algorithm with commas. And the final output is to provide a code with just commas and no other connectivities available to us. So what are the rules of Wang's algorithm? The rules of Wang's algorithm have two types of rules, can be categorized into two. One is called the non-branching rules, and the other is, of course, the branching rules. The first one is for negation. Given P, negation Q or Q and R, sequent P and R, the negation goes from the premise to the conclusion. That is the first rule. So a not X becomes comma X into the conclusion. This is called the negation rule of the Wang's algorithm. The second is when there is an and or a conjunction in the premise. The conjunction is replaced by a comma. So the above formula where you have P, P and Q becomes P, P, Q, implies R, S. The other part of the second formula is where there is a disjunction in the conclusion or the body. R or P. The or is replaced by a comma. The third non-branching rule is for implication. When you have Q implies P, the head of the implication moves to the premise. So here in this case, P or Q, sequent Q implies P, then Q goes to the premise. So you get P or Q, Q, sequent P. Remember that these can undergo further proving. That is, if there are more connectivities, they can be replaced by commas until you reach a formula with only commas as a part of the entire rule. So remember that, for example, here P and Q, Q and R can further be uh, deducted to have only commas in the rules. Now let's look at the branching rules. There are mainly two branching rules. One is if there is an or in the head or in the premise. This or is replaced by two rules. So here we have P or Q, comma R, comma S, sequent Q or P. So the first rule that ends up from here is where you take only the P. So P, comma R, comma S. And the second rule is when you take only the Q. So it results in Q, comma R, comma S, sequent Q or P. Similarly, when you have a conjunction or an and in the conclusion, this results in two rules, one which has the Q and the other which has P. This is the fourth rule that you as part of the Wang's algorithm. The other branching rule is when there is an implication in the premise or the head. In this case, so let's take this P, comma P implies Q as a part of the premise. Then one formula is resulted by taking the tail or the body of the implication and adding it into the head. That is, P, comma P implies Q results in P, comma Q sequent P or Q. The other results by taking the head into the opposite side. P implies Q, P or Q, comma P. Remember, it'll be good to recall writing P or Q in terms of and or or. That will help you see how this formula comes about based on the previous formulas that we have had a look. Now, some of the functions, as we said, is provided for us in the code over here. So the first thing that we will talk about is this op functions. The op functions are used to create a binding for the functions. The higher the score, the lower the binding. So the highest binding is for negation, above for conjunction, disjunction, implication, and the least binding is the sequent. So you have the highest score of 700 provided for sequent. This has been implemented for you already. Another function is the member function. We have seen this before. The member function tells us if there is a value that's present in the list. So let's have a look at how the member function actually works. So let me try to run it for you over here. So I'm providing a variable X and giving a list ABC, and let's run it and see what it says. So it's asking is X A, so saying the next one, it says B, says C, and yes. So it picks any one of them to be the value, and any one of them, if you provide X as A, it will tell yes or no. So say I take the same thing and let's replace X by A and see what it says. It says true. Okay, so that's what is the working of the member function. So it tells us if there is a particular formula available in the list or no. The second such function which we need to know is the delete function. Given a list and a value, it deletes the value from the list and provides us the rest of the list. So here you have X, X tail, X given tail, and it takes out X from the list and gives the remaining list in the tail. So let's again see how this works. So let's say you want to remove A from the list ABC. The remaining of the list should come in X. So it says X is BC, S. Let's give another value. It's a variable. See how this works. So if you're removing A, it removes BC. That's what is the thing. This is how the delete function works. Now let's go into implementation of the exact rules from the Wang's algorithm. The negation rule has been implemented for you as a sample code. It's available in thumbpv.pl. So if you come down, here is the power of the negation rule that's been implemented for you. So what does this do? It checks whether not of a particular formula or a term is available in the list on the left-hand side, that is the premise. If it is, it removes X and gives the remaining list. It writes that this is due to the negation rule. It's by the negation rule that you're doing it. And then it says, puts X in the head of the remainder or the conclusion. Similarly, the second part is where it checks if there is a negation in the conclusion and moves it into the premise. Remember how a list is defined? In X pipe L, L is a list and X is a term. It does not work if you do it the other way around. Okay. Remember again, X is a term and not a list, and L is a list. An example of the branching rules. When you're using the branching rules, it results in more than one rule. Remember that you need to call proof with all the rules. That's why this code isn't complete. It's for you to write it out fully. So here, for example, if you're doing this, you're taking A or B. So one results in A with the rest of the list, while the other results in B with the rest of the list. Both these rules go through the iteration of proof until all the conjectives or all the connectors are removed, and all that remains is just commas. Again, a quick review of the rules before you go into doing this project. So the non-branching rules that you need to implement, one is the conjunction in the head or the premise. The second is disjunction in the conclusion. And the third is an implication in the conclusion. The branching rules, the first is if you have a disjunction or an or in the premise. If you have an and or and in the conclusion. And the third is having an implication in the premise or the head. That's it for project 3. I suppose it's much simpler than doing the chess algorithm, and this is closer to what you have learned in propositional logic. This is one of the theorem proving algorithms, or a very basic theorem proving algorithms. And I hope it helps you learn Prolog and logical programming better. Best wishes with this project. Thank you.